Hi there and welcome. Today we want to see how we can process data in chunks in R using the iotools package. I'm loading the New York City Flights 13 package just to obtain the flights dataset. We're loading the data table package for reading CSV files and also the tidyverse for the same reason, and the micro benchmark package to get some timings, and of course the iotools package, which is the workhorse for processing data in chunks. So we obtain the dataset from the package flights. You see it's loaded lazily here. It's just a promise, but as soon as we access it, we can have a look at it. So it's just over 300,000 rows. We look at the size. It's 38.8 megabytes. So it's not big data in the sense of many gigabytes, but big enough for our example today. And of course you can apply this technique that we will see to much larger data. We save it in two ways, as a native RDS file and as a CSV file. And just showing you the difference, you can see it here in the bottom right in the files pane. The RDS file is stored much more efficiently at 6.6 megabytes compared to 29.8 megabytes for the CSV file. So here the recommendation is avoid the CSV format if possible and rather use a native R format like RDS or RDA if you prefer. But I know that some analysts don't have a choice and you just get supplied data in CSV and you have to start your data analysis workflow with a CSV file. So let's see how we can read in the data. I know there are more dedicated packages, but the main takeaway is you should avoid base R's read.csv function, and we're comparing here tidyverse's read_csv and data table's fread functions. And you see here in the bottom in the console from microbenchmark, we did 3 runs. It's recommended not to rely on a single run because some background processes can influence your measurements, but here the measurements are quite stable in that case. So we see that data table's fread function is almost 10 times faster than tidyverse's readr function, and that in turn is another 3 times faster than base R's read.csv function. So the recommendation is to avoid base R's read.csv function and rather use a dedicated package, and here data table is a lot faster than tidyverse's readr. I know there are more packages, but I think fread is the fastest as far as I know, or at least no other package should be considerably faster than data table's fread function. Okay, but now to our main task, processing data in chunks. We have to supply the column types, and I stored them here in a vector. You see that here, call types is a vector now. We can type it in the console. And now the workhorse for processing data in chunks in the iotools package is the chunk.apply function. And now we have to think a little bit differently than compared to our normal data analysis where all the data is in R's memory, because reading the data and transforming it to an R object are 2 separate steps now in the iotools package. So the data gets read in as a raw vector, so all the data in one vector, and then we have to explicitly transform it to an R object. Here I chose to transform it to a data frame using the dstrsplit function. An alternative would be to transform it to a matrix using the mstrsplit function. Matrices are processed a bit faster than data frames. You can try that out and use timings for that. But of course matrices have the disadvantage of having to be in a unique data type, whereas in data frames you can mix data types. So here we're working on a data frame, and then I have a simple analysis function. In this case I just compute 3 quantiles on one column of the data frame here, and add the number of rows n with a simple one-liner. Of course you can exchange this one-liner by any function or functions that you would like to apply to your data. It could be data preparation steps, it could be data analysis steps, whichever you like to do. So here just a one-liner for a simple example, and you see in this case we get 4 chunks. We have specified the chunk size here. Parallelization unfortunately doesn't work on Windows in this case, so we process the data sequentially here. And you see we get 4 results back the number of rows varies a little bit, and the last chunk is a bit smaller. We could adjust the chunk size here and reduce the chunk size, so you can try out whichever suits your needs best, like how many chunks you want to process. And now half the chunk size corresponds in twice the number of rows, so it's now 8 results or 8 chunks that have been processed. And we can also assign the results to an object. So here I call the object results, and we see it's a matrix or array, but of course we can transform that to a data frame if we prefer. So much for a simple example. I hope this helps. If you like the video, give it a thumbs up and consider subscribing. It really helps the channel. Thank you and all the best for your R projects and data analysis. See you soon. Ciao.